So here we go. I need my calculator. Please don't leave the calculators here over the break. So you can charge them today, no problem, but over the break I would not want them to be left in the room just in case. All right, so here we go. Triangle fun, F is 51. I've got side F, I've got my pair here, and another side. So this is SSA, and it's acute and particular. On the test, I will ask you like how many solutions are possible. That is hint like, hey, make sure you do the triage, right? Figure out how many, 0, 1, or 2. When it comes to solving though, I just finished writing the test, okay? Like it's basically done. When it comes to solving one that has more than one answer, I will tell you. I'll say, hey, this triangle has 2 solutions. You don't have to do what I'm about to do here, like figuring out how many. That'll be separate. So I'll have a section where all I will ask you is like how many triangles are possible. And then another section where you actually have to do some solving, okay? So let's figure out the A part though. That's still good practice. Okay, you do this. This is 51. 9.1. This is angle F. This is side F. And so the other side is here. Which means, okay, now you have to be a bit more careful when you're going to solve later. If this is side U, this is angle U here, potentially, which means that this is angle N up there. Okay, so you kind of let the sides indicate where the angles would go. So here we go. This is string and this is rod. String is shorter than the rod. I have to find the height. I go 10.5, right? The rod here times sine of 51. This is where it's going to slow me down a little bit. But 8.16. I'm timing it a little bit, so 10:38-ish. Let's see how long this takes us. So this is my height. So string, if I compare the string and the height, string is greater than the height. Therefore, 2 solutions, okay? You only have to find the height if the string is shorter than the rod. Note, if the string had been greater than or equal to the rod, you've got 1 triangle. You don't have to find the height. It's a lot simpler. No need to worry about that. It's only when the string is shorter than the rod that you have to do a little bit of extra work. Okay, so here is our sorry, I just want to make sure it's recording. So the first triangle is when it swings out here. I'm going to start with that one. I'm going to go FNU 51, 10.5, 9.1. However, you know that there's 2 solutions. For everything that's missing, there's 2 possible answers. That's what we've just determined. So we're going to go N1, U1, and side N1, like that. Okay? Or the other one is when it swings in, like this. When this string, can we for now just pay attention, okay, for now? I know you're talking math, but just so we can all focus. 51, 10.5, 9.1, F. This would be U and N as well, but I make a distinction. I make a distinction there. So that's what's happening. And so you know, this is your string, okay? So that string that we had dangling earlier is this. It swings out and it swings in. I start with the one where it swings out. Start with the outside, then go inside. That's probably a good one, okay? Start outside, then go inside when it swings in. Okay, I'm going to start with this one. So I go sine of 51 over 9.1, and then it's sine of U1, this angle, over 10.5. Okay, so here we go. Solve that. Sine of U1 is 10.5 times sine of 51 divided by 9.1. Angle U1 is going to be the inverse of whatever we get there. and just bear with me a second here. Sine of 51. It has to start with a 0 or else it's not going to work. Okay, so angle U1 is 63.73 degrees. Okay, so that's one possible answer for angle U. Do you remember what happens now? What do I do to find U2? I will take this with me, and so to find angle U2, I go 180 minus angle U1. That is key here. To find this angle here, I don't have to use sine law all over again, because I'm going to get the same answer. I don't want that. Okay, so it's 180 minus angle 63.73. So angle U2 is 116.27. Okay? So, what you need to understand is if I ask you for angle U, if I ask you in this scenario, solve for angle U, you would stop there and you would just say angle U is 63.73 or 116.27 degrees. That is it. Okay? You would be done at this point. Let's keep going though. Now we can find both n, right? Both angles, potential solutions for n, because we've got two angles for both triangles. So I'm going to go ahead and do that. So angle N1 is 180 minus 51 minus 63.73. Angle N2 is 180 minus 51. Let's go with the 51 first. Okay, this 51. And then take away the 116.27. Remember, you're basically simultaneously working with two triangles every single time. Okay. Angle N1, angle N2. So 180 minus 51 minus 63.73. You get 65.27 here. Okay, that's important. N2. 12.73. So here, you would say that angle N is 65.27 or 12.73. Okay, that would be your answer. If I asked you for angle N, you would stop there, you're done. Okay. Got it? So every angle, every side that you're solving is two possible answers. That's what we're saying here. And then last but not least, what I do at this point is I just focus on this one here, 65.27. I know that this is 10.5 and this is 9.1. And for this triangle, here I've got 12.73. My bad. I know it's not perfect, but it's just to help you out. You don't have to do this. So I'm going to use cosine law twice to solve for angle side N1 and then N2. And here's where I'm going to ask you, if this is confusing for you at that point, the N1, N2, you can call this X if you want and this Y. I'm okay with that. Just call it something else so that when you work with the cosine law, you don't have like the subscripts. So for this one, X squared is 10.5 plus 9.1 minus 2 times 10.5 times 9.1. Cosine of 65.27. Am I missing something? Oh yeah, I'm supposed to square these, right? There we go. We'll figure that out. For this one, I'll call that y. Y squared is the same thing as before. oops, cosine of 1273. Y is square root of this. And here's where I always like to be efficient, to not waste time. This is why I use cosine law. I'm going to show you why I like cosine law for this particular case. So basically, I type this in. So I go 10.5 squared plus 9.1 squared, sorry, minus 2 times 10.5 times 9.1 times cosine of 6527. I figure out what that is. X is, take the square root of that, 10.64. Can I have a few folks nodding? Is this what you got? Yeah, I got more than a few. There we go. I had a feeling I was going to get this wrong for some reason, because when I rush, that's what happens. But we have centimeters? Centimeters. Okay, that's X. And watch this. This is the shortcut. If you want to work with this cosine law here, the only thing that's different is that angle at the back, right? So you go and find that entry and change the 6527 to 12.73. Go hit enter. Take the square root of that, and you got 2.58 centimeters. Is that what we're getting? Hey, so you're doing sine law, you're doing cosine law, you're doing everything multiple times. I do want to make sure you understand, though, that sine law would have been okay still, right? Like if you technically know that this is 51, so you've got your pair, you could use sine law, right, the 12.73 to figure out that side, no problem. I don't object. You do whatever works for you. I'm fine with that. So side N would therefore be 1064 centimeters or 2.58. I'll tell you another, if you're interested in the bonus, I'm not sure yet exactly what the bonus is going to be, but one could be, I give you a word problem where if you sketch it, you realize, oh, this is SSA. This is an SSA case. I need to figure out how many solutions are possible given the word problem. So that could be something that you could expect if you're interested in a bonus. That could be one option. So just keep giving you a heads up. Okay, we're going to go to the back of this, but before I move on, why is this happening? Like why are we doing this? This is due to the ambiguous case of the sine law. Sine law doesn't distinguish between acute and obtuse angles. That is the problem, right? So that's why we have to always investigate when it's an SSA, right? String compared to the rod, what is happening here? Then string compared to the height, what's happening here? We need to narrow it down, okay? And so that's the main reason for it. So let's go to the back here, and let's solve that one. Elijah would like to visit his friend. Please use a ruler for these ones. And maybe if you have a different color to do your compass rose, so you don't mix that up with the side of a triangle. I've seen some of you, when I mark the quiz, you're mixing up the compass rose with the side of your triangle. So I'm going to try it with a color. Elijah leaves home. We're going south 15 west. So I'm just going to position myself before I do my sketch. South west, we're going this way. Right? Stops to refuel, and then we're going west 10 south. We're going this way. So we're actually going in this direction the whole time. So now that I kind of positioned myself, I'm going to sketch this, okay? Maybe the different colors, it might be dangerous because if you make a mistake, erasing that is rather difficult. But I'm going to try this. So south 15 degrees west. That's my first, right? This is the first part. That's 15. Okay, for 13 kilometers. This is my starting point. And then here, I'm stopping and I'm going, there's another compass direction given here. Okay. So let's see how this works. We've got west, 10 south. So west, and we're going 10 south from that. So it's not a big angle, right? We're going this way. And the 10 is right here. Okay, the 10 degrees is right there. And we're going 10 kilometers in that direction. And we refuel here, I call this R, and then we arrive at Dustin's home. Okay, so that's the interpretation here. Try to make your angles comparatively realistic. Okay, I'm not asking you to like get it bang on, but 10 degrees should be, if this is right, your west line, 10 degrees is about that. 45 is cutting that 90 in half, right? So that helps you make a more realistic diagram. Okay, so we want the distance between the two friends. So this is the side that they're asking us for. That's the ultimate question. Let's make our clean, anywhere in here, a clean version of this. So I'm going to bring this over here. I copy that angle over here. And then I have this, right? So my start, my refueling, and Dustin's home. This is what we're asking for. 13, 10. How many angles will come into our clean version? 1. Like let's just make that clear. You will be able to get 1 in there. Sometimes there is the exception when you're right on the east-west line, then it's a little different. So anyways, let's try to come up with, we know that we have a full 90 degree in this corner. We can count that. So it's 10, 90, and we need to figure out this little wedge here. We bring that 15 in there. Okay? Wait for now, okay, guys? In a bit, I'm done, and then you can talk again. So 10, 90, and 15. That would be 115. So the 115 comes in here. What kind of law are we talking about? SAS, right? Cosine law? I think I'm going to cosine of 115. X is equal to. Can I have a few folks telling me what the answer is? Anybody willing to yell out a number? 1946? 1946. I got a bunch of nods. Thank you. I'm just going to go with that, okay, just for time's sake. I want you to have a little bit of time to kind of gather your thoughts later. But we've done one of these just in the previous page, so I think we're okay here. Thank you. So as I'm telling you, I hope that if you've done your homework, if you've watched my lessons, we've done several scenarios, and they're not always the same. Okay, so you have to be careful. Keep going. Search and rescue. We have a training exercise. North 25 west. That's where we're flying first. So I'm just going to position myself. North west, right? So north 25. So it's about this way first. Then turned. Now we're going south 51 west. We're going this way. So that's kind of what I'm expecting in my diagram. I'm going to erase that in a bit because I need that space most likely. But I'm going to start here, right? So my diagram is going to be somewhere here. Maybe do the different colors once you've kind of figured out which way we're going, right? So north 25 west is about, I would say about that, okay? So 25 is in here. And then we've got, this is 45 kilometers. And then we have, we're turning south. We're turning south 51 west. So south 51, this is 45, 51 is a little bit more. And we're flying this way. Just make sure you don't line up perfectly with your starting point, because then you're going to be tempted to bring in angles that aren't there. I'm just going to make it like that. So this is my start. This is the turning point, and this is where I end up. Okay? What does it say? The destination is 75 from the heliport where I started. So in this case, this side here is what they give you. This was on the quiz as well. Okay, so 75 kilometers is right there. Which means you have moving parts. Oh, I forgot the 51. Sorry, the 51 goes right in here. So bring stuff over, right? You got your vertical line and a vertical line. These are parallel. So bring the 25 in there. Okay. Then you add that up. That is 56, 76. Was this on the quiz? Was this the exact same one on the quiz? I'm not sure. They sometimes look alike, but they're not. Okay. If I don't ask you to make a clean diagram, that is up to you. I really like clean versions. Start, or you can call it the heliport, the turning point, and the final destination. And you bring the 76 in here. This is 45. This is 75. And you recognize that this is sine law, right? You've got a pair. What is it asking for? The total distance traveled. So this is a lot of, we ultimately want to know that last side so we can add it up. We can add up the 45 and this side because we traveled this way and then we have to add this. So this has more than just meets the eye, okay? So let's call this x. Can I solve for side x just like that, as is? No, you need to solve for angle h before you can solve for this. So the only thing we can do at first is solve for angle d because we have that side. So let's go for it. I might ask you again for answers, so if you're ready. Sine of d over 45. Sine of d is multiplying. I hope that solving at this point is not something you struggle with. It's just setting it up and interpreting it correctly. It's going to be 0 something. What is angle d? Anybody willing? Shkina? 35.60? Yeah? I have a bunch of folks nodding. Thank you. Yeah, so that's important. I would give you on your test, okay? I will most likely give you 2 marks for this and 1 mark for the clean. When you do the clean version, I'm looking for that angle that you have to have derived, okay, for this to work. And then I'll give you 2 marks for the first angle, okay, for the sine law getting to the first angle. Now we need to find angle h. That's 180 minus 76 minus 3560. I can handle that. That's 68.4, 40. Okay, that's another mark. And now you can use whatever you feel like using. If you want to use cosine law because you've got side angle side, right? Because you've got this angle now, that's up to you. If you want to use sine law again, right here, and this will give you that, that's up to you. So how about that? I'll use cosine law just because I like cosine law a little bit more. But I don't care what you use, as long as it's consistent. So that's the 68.40. What do we get there? How about that side of the room? Anybody? Marianne? No? No. Peyton? For that last side. Yeah. 7187? Is that what we're getting? That's just this, right, Peyton? So that would be in kilometers. Total would be 7187 plus 45. Because the way the question was worded, there was more than just that. 116.87. Is that what we're getting? If you add, because it asks for the total distance traveled. Yeah.
Why do you use 75? 91.89 plus 45 plus 75.
Are you asking about this here?
No, the total.
This?
Yeah.
Because the question asked, determine the total distance the crew traveled. So the helicopter starts here, flies 45, and then flies to the destination. So we need to add these two only. I guess, are you saying it went all the way back? Or if it's a round trip? I'll be specific.
Okay.
If it asks you, like, how much was traveled in total coming back to the heliport, then you would want to add 75 as well. Good. That's a valid point. Are we good with this number? Those of you that did it? Yeah? Okay. Thank you, guys. That helped me a lot because I didn't have my key handy, and it's